Hello, I'm Kaylee.
And I'm Chris.
Today we are going to be talking about gross primary production, net primary production, net ecosystem production, and their functional use in the analysis of an ecosystem's carbon budget.
These three terms are useful for scientists who are trying to understand the carbon sequestration potential of a terrestrial environment. Identifying differences in the NPP, NEP, and GPP is important because it can vary with species composition, structure, and climate.
Before we start to define GPP, NEP, and NPP, let's first talk about what an ecosystem's primary production entails. Primary production is when autotrophs, organisms that can make their own energy, use biological processes such as photosynthesis to create new chemical compounds, such as glucose, that result in biomass.
Now, let's define these terms.
GPP is the total amount of carbon fixed by an ecosystem over a specified time.
NPP is the total amount of carbon stored in plant biomass. However, NPP only takes into account the carbon that is left behind after plants' respiration, which is about 50%. Therefore, NPP equals GPP minus R. To explain these using a more relatable example, we'll use money. Imagine you have a job that pays $500 a week. This $500 is your GPP, the total amount you've made over a week. Now, it would be nice to pocket that $500, but you have to buy food and pay for gas, which adds up to take away 50% of your income. These payments are like respiration, and the $250 left over is your NPP. Lastly, NEP is the carbon that is left in an ecosystem after plant and herbivore respiration, as well as decomposition. Therefore, NEP equals GPP minus the respiration of herbivores, plus the respiration of plants, plus the respiration of decomposers.
Now you may be thinking that NPP should result in an equal amount of plant growth, but that's not true. Some NPP is lost to herbivory, fires, and litterfall. Only after these external factors does the true increment, or remaining NPP, add to biomass.
There is also variation in NPP based on the length of the growing season, temperature, and moisture. NPP is greatest in areas of increased temperature and moisture, and these two characteristics coincide at none other than the equator. This is why this area is full of lush tropical rainforests such as the Amazon.
Understanding the carbon sequestration potential of an environment allows us to understand how atmospheric carbon is removed and stored, which gives us insight into how climate change will affect different regions' ecosystems. For example, a study conducted looking at NPP changes in arid and semi-arid areas of China from 1980 to 2014 found that annual NPP decreased by 10.9 grams of carbon per meter squared per year, during an annual decrease in precipitation. However, as atmospheric CO2 concentration increased due to combustion of fossil fuels over the 34-year time span, this decrease was offset by an NPP increase of 14.9 grams of carbon per meter squared per year. Climate change is predicted to have an effect on the strength and frequency of rainfall. If rainfall occurs less often and occurs in heavy bursts when it does, the soil will not have time to soak up the rain before it runs off. This means less water available to be taken up by plants. Supported by the Fang et al. Study, less rain will predictably result in a decrease in NPP. However, this may be offset by an increasing amount of CO2 due to increased fossil fuel combustion.
Additionally, changes in NPP, GPP, and NEP can help researchers understand how climate-dependent natural disturbances and biological processes are influencing ecosystems on a large scale. For example, due to climate change, North American boreal forests are projected to experience an increase in forest fires and other natural disturbances like insects. This would cause dramatic changes in the forest growth and age class structure, which in turn would decrease the forest's ability to store carbon. The study
As you can see, understanding GPP, NPP, and NEP has real-life applications and can help solve problems that are affecting ecosystems around the globe.